Good afternoon. I am one of 6 scientists who worked on the Feasibility Study Draft regarding sea otter reintroduction in Oregon. Today, I am going to provide a summary of Chapter 6 of this draft, which was authored by myself, Dr. Tim Tinker, and Dr. Bodkin. Let me share my screen to start the presentation. As a long-time Oregon resident, my task was to evaluate the habitat suitability of Oregon's nearshore ocean for sea otters. The presence of sea otters in nearshore marine habitats depends on a number of characteristics. Habitat and prey abundance are paramount, as are ocean depth and the coastal geography. All coastal habitats in Oregon can be considered potentially suitable habitat for sea otters. But it is important we recognize that some areas of Oregon have a much higher potential to support sea otters than other areas. The resource most critical for sea otter survival, of course, is access to sufficient and suitable prey. Sea otters are known to consume more than 150 different species of prey, but they are primarily bottom-dwelling marine invertebrates in the intertidal and in shallow subtidal zones. Prey resources are determined by the type of the habitat. The Oregon coast is essentially a linear feature, interspersed with river mouths that form estuaries as they meet the ocean. The nearshore coastal habitat range from hard rock substrate through to sands and mud plains. And for simplicity, we can classify them into 2 categories, rocky reefs and soft sediment habitats. And the prey resources in those 2 habitats are going to differ. Oregon's Nearshore Strategy website provides an overview of the substrate in coastal waters. Map number 1 on the far left shows the north of the state. And as you move to the right, the maps 2, 3, and 4 show the substrates further south. Rock areas are red, blues are boulder and cobble, and the other colors are soft sediment. The black line on the outer limit of the coast is Oregon's territorial waters. That's 3 miles offshore. Starting with map number 1, it's clear that there is limited rock substrate in the northern part of the state. Moving south to map number 2, you can see some scattered rock outcrops shown there in red off of Siletz, Depot, and Yaquina Bays. Map number 3 reflects that long stretch of sandy beach and the extensive dune field from Florence to Coos Bay. And it's only as you get south of Coos Bay to the Cape Arago region and down to Bandon that you begin to again see rock substrate. It is in the very, it is in the very south of the state from Cape Arago to the California border that you find the most substantial rocky areas, as you can see in map number 4. A more detailed habitat substrate characteristics for some of Oregon's coastal waters is available from the Active Tectonics and Seafloor Mapping Lab at Oregon State University. Here is one example from the near shore of Humbug Mountain, south of Port Orford. Again, rock is red, boulders are blue, and soft sediments are yellow and orange. There are 17 of these maps in Appendix B of the Draft Feasibility Study, and they provide a good overview for assessing habitat suitable for supporting sea otter populations in Oregon. First, let's look at rocky reef habitats. Rocky reefs are places that provide prey resources and suitable resting areas for sea otters. Rock reefs at suitable depths often support kelp populations. In Oregon, the primary kelp of kelp beds is the bull kelp, Nereocystis. The giant kelp, more common in California, is found only at Cape Arago, south of Coos Bay. Many of you will have heard the presentation by Sarah Hamilton regarding kelp resources in Oregon yesterday, so I'm not going to go into any depth on this subject here. Enough to say that in general, where there's extensive, stable rocky habitat in relatively shallow depths, you will find kelp. Several areas of Oregon coast fit this description. Starting in the north, there are scattered kelp beds in the vicinity of Depot Bay, but it is in the south of the state where we find the most extensive kelp community, as you would expect, because of the presence of the existing rock habitat. The immediate nearshore areas of Cape Arago and of Redfish Rocks and the rock habitats of the Orford and Rogue Reef are notable for their abundance of kelp habitat. Kelp beds also support a diverse suite of prey otter resources. They include the purple and red sea urchins, various marine snails, octopus, crab, mussels, chitons, abalone, and many other small invertebrates that attach to kelp or to the rocks. Research has shown that in the early stages of sea otter population establishment in rocky reef areas, urchins almost always represent a core part of the diet. For the majority of the potential prey species in Oregon, however, there are little data on abundance and few consistent monitoring efforts to provide that kind of data. In other words, we don't know a lot about those other invertebrates, potential invertebrate prey resources. There are, however, a few exceptions. Because Oregon has been devoid of sea otters for over a century, urchin populations have not been subject to otter predation, and numbers were unnaturally high. This allowed for a commercial harvest of red sea urchins, and the Oregon Department of Fish and Wildlife collects information on landings. This graph shows the annual urchin harvest from the beginning of the commercial fishery to the mid-2010s. Virgin stocks were quickly reduced, and by 1996, the urchin fishery boom was over. From 1996 to 2015, the urchery fishing landings stabilized at a much lower level, and they've continued to be at that level to the present day. The principal area of harvest, reflecting the major area of abundance, is in southern Oregon, and about 75% of the harvest is from Orford and Rogue Reefs. The other 25% are from the nearshore areas of Brookings, Cape Arago, and Depot Bay. The smaller purple sea urchins account for only about 1% of the harvest. California sea cucumbers, a prey species of sea otters, are also covered by an urchin permit, though harvest of this species in Oregon has been very minimal. Again, we know about abalone, a sea otter prey item, because they are regulated by the Oregon Department of Fish and Wildlife. 3 species of abalone occur in Oregon. The red abalone is limited to a very few small areas and only occurs from Cape Arago south. There was a short-lived commercial fishery from 1960 to 1962 and a recreational fishery until 2017. Both are now closed because of the concerns of overharvesting, and numbers of red abalone are exceedingly low in Oregon. Flat abalone are found in vegetated rocks throughout Oregon. They were commercially harvested from 2001 to 2008, when the fishery was then closed, again due to concerns about low numbers of animals. Pinto abalone is a small species which ranges from Baja to Alaska, but this species is very rare in Oregon. There are no commercial and no recreational collection of abalone, of any of the species of abalone in Oregon at present time. One other potential sea otter prey species for which there are data are rock scallops. These are bivalves that attach to rock substrate and are taken under permit by recreational divers. The harvest is relatively small, averaging about 800 individuals per year, as you can see in this graph, and 50% of the take was returned to the ports of Charleston, Port Orford, and Brookings, reflecting the area of abundance in the southern part of Oregon. The data I've just presented are but a few of the species which are likely prey items for sea otters. There's very little data on abundances of species such as turban snails, kelp crabs, octopuses, sea cucumbers, and the myriad of other invertebrates that are likely to be prey items. We are, however, beginning to learn about abundance of some other invertebrates that are potential sea otter prey from scuba surveys conducted in Oregon's 5 marine reserves, shown here on this map. We also know about intertidal populations because surveys have been conducted by a number of researchers in these reserves. However, there is only one reserve in the southern half of the state, the Redfish Rocks, south of Port Orford. So the data on non-commercial invertebrates are limited for the area of the state with the largest rock habitat. Canopy-forming kelp beds not only provide habitat for sea otter foraging, but they're important for behaviors such as resting, grooming, hanging out, and pup rearing. We should not think of kelp beds as the only habitat, though, that supports sea otters. High density of sea otters can be found in open coastal habitats exposed to high seas and winds, such as these at Cape Arago. They appear to offer little in the way of shelter, but sea otters are often found in these areas. Examples where this occurs include the sea otter populations of the Bering Sea north of the Alaska Peninsula and the sea otters found off the coast of Washington. Sea otters also forage in areas of soft sediment substrates. Here, their diet consists of species dwelling within the sediment, such as clams and worms, and more mobile creatures, such as crabs. Sea otter soft sediment habitats can be further divided into the outer coast areas where, other than Dungeness crab, which was the topic of yesterday's presentation by Dr. Alan Shanks, we know very little about the organisms that live there. A second soft substrate habitat is found in estuaries, where we do have considerably more information about potential sea otter prey items. Throughout their present and historically occupied range, sea otters use, or they have used, estuarine habitats. The Oregon coast has 22 estuaries, as you can see here in this map, ranging from those whose rivers start in the Cascade Mountains to some that have such limited freshwater input that they're essentially saltwater lagoons. Several of these estuaries have large areas that can provide suitable habitat for sea otters. Some have significant areas of eelgrass that can provide resting and nursery habitat for sea otters. This map shows 7 estuaries that have relatively significant eelgrass populations, as noted by those green regions on the map. Estuaries south of Coos Bay, however, are small, with very little tideland and no significant eelgrass. Several surveys have characterized the abundance of eelgrass in Oregon's estuaries. This table summarizes data from 3 studies that are relevant to the potential quality of the eelgrass habitat for sea otter residents. Each of the surveys used a different data source, but there was a common conclusion that Coos, Umpqua, Alsea, Yaquina, and Tillamook bays have the most substantial eelgrass resources, and that most other Oregon estuaries are either devoid of eelgrass or have only limited amounts. Sea otters in southeast Alaska commonly move from areas with eelgrass to rock habitats with kelp. So one additional criterion that would increase an estuary's suitability for sea otters is the presence of adjacent kelp beds. Yaquina and Coos Bay meet this criteria. Estuaries also provide rich invertebrate prey resources for sea otters. Major prey items are a variety of crabs, clams, mussels, and worms, all of which are abundant in Oregon's estuaries. Again, because there is commercial and recreational harvest of some of these species, there are data for some invertebrate populations in these estuaries. For example, the clam resources of 6 of Oregon's estuaries, where significant recreational clamming occurs, have been well documented by ODFW's Sea Corps program. The example here is for 4 species of clam surveyed at Bridge Flat, Yaquina in 2012. These surveys are also available for clam populations in Tillamook, Netarts, Siletz, Yaquina, Alsea, and Coos Bay. Commercial clamming also occurs in Oregon's estuaries, but only in Tillamook Bay is there a significant commercial harvest of bay clams, as you can see from this graph. Several species of crabs suitable for sea otter consumption occur in Oregon's estuaries, and recreational crabbing for Dungeness crab occurs in all bays where species is present. 4 of Oregon's estuaries support commercial oyster farms. There's very little published information about whether sea otters consume oysters. Based on anecdotal reports, in areas where sea otters and commercial oyster operations overlap in Alaska, there have been minimal interactions. However, unlike the Oregon fishery, where the majority of oysters are grown directly on the estuarine bottom, as seen here, the Alaska operation utilizes hanging bags or enclosures that may discourage sea otter interactions. My task was to see if the habitat characteristics of Oregon's coastal ocean was still suitable for sea otter survival. Looking at what we know about Oregon's estuaries, here is a summary of characteristics for 8 estuaries that is relevant for their assessment as a potential site for sea otter reintroduction. The size of the estuary and the presence of eelgrass communities gives an indication of the availability for foraging and for resting habitat for otters. The existence of commercial or recreational harvest activities can be viewed as a positive indicator of the potential prey availability. However, these fisheries and the presence of oyster farming and shipping activities also represent a potential for human-otter conflicts in the case of sea otter recolonization. This summary suggests that 3 larger estuaries, Tillamook, Yaquina, and Coos, have an optimal combination of prey resources, they have clams, crabs, and resting habitats, the eelgrass beds, tidal creeks, suggesting they could potentially support viable sea otter populations. Yaquina and Coos Bay have the additional advantage of proximity to outer coast reefs and kelp beds that could provide alternative habitats for establishing sea otter populations. Likewise, in terms of outer coastal habitats, the data indicates there are several areas of the coast that could be potential sites for sea otter reintroduction that have relevant habitat features and prey populations. These occur primarily in the southern half of the state, where rock habitat and kelp beds are more common. They include the Depot Bay, Yaquina Head region, Cape Arago, south of Coos Bay, and the reef complexes near and to the south of Port Orford and Gold Beach.